Welcome everybody to this event. It's linked to the International Women in Engineering Day, which will be on Sunday. And we are going to showcase the research carried out by our amazing women. So we can start. And our first speaker will be our Director of Research, Professor Tony Gladin. Tony is a professor of environmental health and has been researching issues surrounding particulates, bioaerosols, health and waste management since 1993, starting at the University of Bedfordshire and then moving here at the Open University. As I said, she is now Director of Research at the School of Engineering and Innovation, and today she will give an overview of the research we carry out at our school, and then she will share the showcase presentations by some of our amazing colleagues. So over to you, Tony.
First off, can you see the presentation? Has it loaded?
I can see it, yes.
Yep. Yes. So can I ask, if you're not presenting, to turn off your camera, please? Brilliant. Okay, so good morning, everyone. Really exciting to talk to you all about women in engineering. I'm going to talk a little bit about the School of Engineering and Innovation and some of the research that goes on in the school, but I'm also going to reflect a little bit more on the national picture, if you like, in terms of women in engineering and research, just very briefly. So I'm only going to talk for about 5 minutes, and then I'm going to be introducing each speaker in turn. We've got about 6 speakers who are going to talk about their own research. And if you could please, each speaker, put your camera on as you go along, and then everybody else make sure theirs are off and everybody else make sure they're muted. That'd be very useful. And I'm assuming we're going to have a roundup of questions and a session at the end with a general discussion. So we won't pause for questions in between. But if you do have a burning question, by all means, feel free to put it in the chat. Okay, so without further ado, I'm going to talk a little bit now about engineering innovation as a whole, and hopefully I can advance these slides. Okay. So this is more or less the structure of the session, which I just mentioned. So I'm going to talk about research, then we're going to have a showcase of various people, then we're going to have a panel discussion with plan to close by 1:30. Okay, so this is a busy slide, but I think it's important to set the context a little bit in our school. So we are a big school within STEM at the Open University. So we have around 70 to 80 academic and academic related staff in our school. Actually, bucking the national average, as you might say, we are more or less evenly split between male and female. We have 5 main areas of research in the school, which we've organised into clusters. This is really to get critical mass within each of these areas. So we have an engineering cluster, which incorporates things like materials, energy, and all those kinds of things, including not only the technical aspects, but policy. We have a design cluster, which you'll hear from some of the colleagues today, who do various types of design research. We have a sustainability in the built environment cluster. We have waste management people in that cluster, acoustics, environmental governance, water, all sorts of things in that cluster. An applied systems thinking in practice cluster, and education, where people do scholarship and of teaching and learning. in the last REF, which is the research assessment exercise that all universities undergo every few years, unusually within even the university, E&I was entered into 6 different units of assessment. For most schools, they have 1, maybe 2 units of assessment. So that really reflects the diversity of our teaching and of our research, I think. So about 46 of our staff were entered. We led actually 3 of those units of assessment as well. And I think we had a reasonably successful REF. In particular, design had 100% of 3 and 4 star research, but B12 also did very well, and B7 is up and coming and is definitely going to be stronger than next REF, I'm sure of that. But the school also contributed to significant 3 and 4 star impact cases. And the diversity of the impact cases, I think, is of interest and shows all of the research that the school does. So everything from the sustainable design to Blue Planet 2 and Blue Planet Live, where we were contributed to a 4 star case study there, waste management stuff. So we had a wide range of topics. But of course, that was REF 2021. We're now all looking towards REF 2029. But I thought it was interesting to reflect on a couple of things, because we are talking about women in engineering today. The impact of being female on the likelihood of submission is an interesting one, because it's pretty much accepted nationally that if you have male and female staff in a department, particularly a STEM type department, then it's more likely that the men will have a research orientated role. And that is actually reflected slightly in the figures. And if you are there's 4 main panels basically: A, B, C, and D. A is medical and biomedical and veterinary sciences. B is things like biology, physics, environmental science, and engineering. C is more things like law and education, and D is more social sciences, but also design comes into that area. So it's quite clear that if you are female and in a biomedical science or engineering, or to some extent law and education, then you are less likely to be submitted to REF. So that's a kind of an interesting outcome. So if we take all the panels into consideration, it's not statistically significant. But if we look individually at A, B, and C, then it is statistically significant. So in STEM, as a woman, it's more challenging to be in a research role, should we say. But I don't think that tells the whole story. And the whole story is also in the absolute numbers. So if we look at eligible head count, so we've got men, we've got women, we've got the main panels. The thing that really stuck out to me and I thought was notable is if you look at the panel B, in which engineering, B12 falls, but also the environmental side, which we have a big submission to. It's the absolute number of females, which is the most striking thing to me. In all the other panels, it's kind of even. It's more or less 50-50 male-female split. But in B, only 20% of women comprise of a research submission in B. And I thought that was in and of itself a really striking figure. Okay, let's talk a little bit more about E&I again. So we have a very active grant portfolio. At the moment, we've got around 21 currently funded projects worth around 2 million. And I think that's, for the majority of our activity, if you like, in E&I is teaching, because we deliver all sorts of engineering, environmental, and design qualifications. But we still find time for research. And actually, the research split between male and female isn't too notable. In other words, we have similar submission rates between our male and female staff. So we had around 45 bids submitted in the past 12 months. And we also have had an active development of new impact cases school day. So I think the future looks pretty good. There's a lot of potential in the school, and I know that we have lots of bids in the pipeline as well. But we have had some notable successes as well in the last year or so. So on the whole, I think things are looking very positive. But, you know, we don't want to sit on our laurels, so we are still working towards developing our female staff, but also all of our ECRs in particular, to make sure that they have the same opportunities. And that means we give them sequel funding, and we help and identify new and emerging areas of research. We also support impact activities and knowledge exchange because we want more industry engagement. We are an engineering department. We do design work, we do environmental stuff. These all have real world impact. So we obviously want to, yes, thanks, Sylvia. We obviously want to make sure that we have, you know, a future pipeline of good research. And the only other thing I'd like to say is, you know, we obviously collaborate with other schools in the faculty. So we have active research going with our space science people, with our environment and ecosystems people. And we also have a number of what we call in the OU OSCs, and these are open societal challenges. And basically, this is a vehicle by which the Vice Chancellor of Research has used to fund our impact and knowledge exchange activities, or at least it's becoming that way. So I'm going to stop sharing now because that's the end of everything that I was going to say today. And at this point, do we want a couple of minutes for if anybody wants a quick question, or shall we move on? What would you like to do, Sylvia?
I don't
mind.
see any question in the chat, so I think we can go on.
No, let's carry on. Yeah. Okay, great. Have I stopped sharing? That'd be very helpful if you could just.
Yes, you have.
Yes.
Yeah, brilliant. Okay, so we'll go on now to our showcase and our 5 to 6 minute talks, of which we have, let me see, 1, 2, 3, 4, 5, 6. And we're going to start with a colleague called Lisa Bowers. Lisa is an inclusive designer at the Open University. She designs novel assistive technology, specifically touch-led haptic technology for people living with varied ability needs and sensory impairments. So if you could introduce yourself, Lisa, and have a little chat about your research, that would be great.
Thank you, Tony. Okay, let me just share my screen. Oh, a moment. Can everybody see the screen I'm sharing, first off?
Yes, I can.
Oh, so good morning, colleagues. I'm a inclusive designer, I would say first. I'm going to present to you this morning. I've got a feeling examining the use of haptics, machine haptics technology to support others' senses, to support our other senses. Consider for me, if you will, all of your senses, all of your 5 ocular, olfactory, haptic, audio senses, and understand which one you think you lean on the most. Which one do you think that working every day, when you're looking at the screen, when you're listening to music, when you're watching a film, when you're reaching for an object, when you're tapping on the keyboard, which ones do you use the most? Well, considerably, you would be surprised to note that we do use our hearing and sight more. However, contrary to popular belief, from when we were infants, touch is actually our first sense. Certainly in the womb, when we're born as an infant to our parents, touch is the one sense element that creates a good bonding connection with our parents and other people. It creates a sense of warmth and feeling and a sense of security. touch is exceptionally important to us. But from all of those senses, what if one of them was taken away? What if you couldn't see? God forbid, but I work with people who can't see and who have a varied limited sight. I've even worked with people that a noise, echolocation can disrupt their sight because their senses are struggling with various condition. So for the last 15, 16 years, I've been working with human haptics and digital or machine haptics. From the slide here, you can understand that we have two main forms of haptics, certainly two main forms that are copied by a machine. But in various sense within the body, we have a lot more refinements and grayscale of touch. So within our tactile, so within things that you touch with your skin, that you can feel vibration, you can feel temperature, you can feel heat, you can feel pressure. With our kinesthetic, various positions of the arm in the body and the arm in space, you can actually understand kinesthetically where you are, where your position is, where your orientation is in space. If you hold your arm out of your visual gaze, then you can understand where your arm is, and for that your somatosensory cortex tells you where it is in the brain. All of our senses are guided and there to protect us from gaining any particular danger and getting away from danger, but also understanding a sense of peace and tranquility and a feeling of security all comes through touch. If you were teaching and working with visual graphics and you were looking at the image on the screen now and you were trying to ascertain and inform someone who had no sight how you would access that image more accessibly, how they would access that image and fully understand it for themselves, not just because someone else is telling them about it, and not just because they've heard it over a transcription. You would find it quite difficult. It's a quite complex, layered, multi-sectioned, really difficult texture to explain and to understand if you don't have the sense of sight. So I turn to haptics. For the engineers amongst us, this is a haptic architecture plan. So we have the haptic device on the left-hand side, so that's the ingoing haptic device and all of the various architectures that render force, collision detection, so when a haptic stylus becomes in contact with something and how that reacts, and force control, and then the graphics that you're seeing on the screen. So you would see the graphics of what you're feeling on the screen. So if it was a circular or a sphere, then you would see the sphere on the screen and you'd be able to feel the spheres round the edges, and you'll be able to pick up the sphere and throw it in the air and pick it back up again and feel the weight of the sphere or the ball. So again, for my engineering colleagues, this is this is being scrapped specifically so students can have a look inside. So the stylus there is what the person is holding, and they are holding the stylus that is connected to the robotic arm. That is connected to a reversible gimbal, which is 6 degrees of freedom. This is what we call a phantom sensible haptic touch, or it's currently called Geomagic. The gimbal is a reverse sense motor, which as soon as you start touching things on the screen, and that interprets digital data that reverses the engineer of that gimbal rotating ball. So therefore you can touch what you feel on the screen and you're receiving a reverse engineered force. So you believe that what you're touching is solid when actually it's all an illusion. It's the closest that we have to connecting with what we do every day is touch and feel. So in 2021, I worked with Happy, Haptic Authoring Pipeline, for production of immersive experiences. And we gained 1.25 million to work with haptics that you can see on the screen, which is a falcon. It's 3 degrees of freedom, and we used it to draw, and we used it with non-sighted and sight-impaired individuals. This is the kind of visual data that we gained from our interface. This is a gentleman who hasn't seen in his life before, except this is partway through drawing clearly of a shark. He's never seen a shark, he doesn't understand a shark, and yet he knew the line was not fully connected. He knew that there was a gap where the white spot is on the screen on the shark's tail. He knew also that there was a disconnect between the fin and the dorsal, and he widened it by pulling the shapes apart because he realized that they needed to be wider. Working with this community fascinates and intrigues me in equal measure as I work forward. The base understanding that they have and then their own adaptations is phenomenal. We had some amazing outputs from this particular project, and we worked with a group of individuals on what we call a meta creative. So someone was in London and they had a piece of fabric that someone else on the outskirts of London who was non-sighted was able to thread. So we stitched fabric in 2 different places with 3 different actors, and one of those was non-sighted. It's engaging work, it's incredible work, and I am very fortunate to be able to work in this area. And I would invite any questions.
Thanks very much, Lisa. I think we're going to do questions and a roundup at the end. Okay, that was great. Thanks very much. It was really interesting. Okay, so we're going to move on to our second presentation this morning. This one is from Sadria, who is a 3rd-year PhD student in materials engineering and science. Her research focuses on developing and synthesizing 2-dimensional materials that respond to light as photocatalysts for removing the pollutants from wastewater. By all means, crack on.
Thank you, Danny. So let me first just share my screen. Can you see my PowerPoint now?
I can see it.
All okay.
Yeah, put it in presentation mode so it will be bigger.
Yes. Yeah. All right.
Thank you.
Hi, everyone. I'm glad to be here and celebrate International Women Engineering Day with all of you. My name is Sadria Madian. I'm a 3rd-year PhD student in materials engineering and science. My PhD research focuses on the advanced functionalized materials for energy generation and environmental remediation, specifically wastewater treatment. So today I've prepared a very short presentation to give an overview of my research, and hopefully you will like it. Start with introduction. Nowadays, wastewater with different harmful contaminants is released from different industries such as textile, which can pose significant threats to human health and environment. Therefore, this wastewater needs to be treated before discharging to our environment in order to reduce the negative environmental and health impacts. As we know that there are many materials and there are different types of wastewater treatment methods that we can use to eliminate the pollutants from the water bodies. However, in my PhD, in case of materials, I focus on the nanostructured materials, which have the dimension in the range of 1 to 100 nanometer. And this kind of material can be divided into different categories that you can see in this figure. But I work on 2-dimensional materials that you can. Let me just that you can see here 2-dimensional materials, and the dimension of this material in one direction is less than 100 nanometer, and it has the layered structure like a sheet. And they have really outstanding properties, which can improve the process of the wastewater treatment. And in terms of the methods that I'm using to treat the wastewater, the process is called photocatalysis, and this word is composed of two other words. Photo means light, and it can be sunlight too, and catalysis is a process when a material, in my research, two-dimensional material, participate in modifying the rate, in the modifying the reaction, um, in the reaction to remove the dyes or pollutant from the wastewater. So in this process, pollutant, the light can be sunlight, and the material, they will interact to each other and produce clean water. Here, this image shows a lab scale photocatalytic reactor. This one is a dye or textile wastewater that we are using. This wastewater passes through the reactor, this tube, and in this tube, the materials will be contacted with the wastewater, and after shining the light, we will have the clean water here. I just want to show you the layered structure of nanomaterials that I'm using. These pictures were taken by me at Open University using a scanning electron microscope, SEM. This equipment can help us to see the morphology and to calculate the size of our materials. This presentation was a very short presentation of my research in my PhD, and I hope that it has inspired you, and this presentation showed you the potential of engineering to solve the global challenges. If you have any questions, happy to respond. Yeah.
Thank you ever so much. That was great. That was really interesting. Okay, so we're going to move on now to our next speaker. And we'll do questions at the end, if that's all right. So our next speaker is Freya Wise. Freya is a postdoctoral researcher in E&I and visiting fellow at the OU, focusing on sustainability in the built environment. She completed her OU PhD in 2022. She has worked as a researcher at London South Bank University's Net Zero Building Centre and is a consultant for Historic England on heritage and embodied carbon. Over to you for your 5 minutes, Freya.
So, good morning. I'm Freya, and I'm interested in sustainability in the built environment because buildings and construction account for around 40% of global carbon emissions every year. My research mostly focuses on reducing carbon from residential buildings through retrofit, carbon reduction from heritage buildings, and embodied and whole life carbon. My interdisciplinary PhD investigated carbon reduction and heritage retention in vernacular homes, and I combined and triangulated multiple methods, including residence surveys, in-depth case studies, evaluating different energy simulation tools, and modelling the operational and embodied carbon potential of different retrofits. If the technology works, I'm hopefully going to share a short video with you describing my research. So hopefully you can see that, and someone wave at me if the sound isn't working. Energy used in buildings leads to around 27% of current carbon emissions and must be halved by 2030. In the UK and Europe, there is little new construction, so we must focus on retrofitting existing buildings. My research examined carbon reduction from the many residential buildings with heritage value, and it matters because it shows that we need a more holistic view of how residents and their buildings interact. Experts often overlook the heritage values that residents invest in their homes, but these values affect which retrofits are acceptable in both designated and undesignated buildings. Most retrofit is resident-led, and residents won't enact unacceptable changes. For retrofit, we must think not just about technical measures, but also behaviours, because it's people, not buildings, that use energy to live and maintain comfort. Widespread behaviour change is needed to reach carbon targets and can make greater carbon savings than many technical changes. I found that our current tools are very poor at assessing real heritage building performance, and the results don't lead to good decisions. We therefore need better modelling tools. We must also assess the embodied carbon of retrofits. Embodied carbon is that required to produce, transport, install, maintain, and finally dispose of a retrofit, and isn't currently assessed for most projects. I found that embodied carbon can determine which retrofits lead to the greatest overall carbon savings. It's therefore crucial that we assess embodied, not just operational impacts. My research matters because current approaches aren't leading to the speed and scale of change required to meet our critical climate goals. With the more holistic approach I've outlined, average life cycle energy and carbon savings of 50 to 60% are realistically possible for heritage buildings and are also much more likely to be enacted in reality. Okay, and now I'll jump into my slides. So, since I completed my PhD, I've been involved in a range of postdoctoral research projects, and I'd like to briefly mention 3 of them. The first involved research with multiple stakeholders to design residential retrofit services for a local authority partnership in Gloucestershire and to identify barriers to retrofit. We found that while financial costs are really important, other barriers such as information and finding skilled installers are also critical. In particular, we found that households often struggle with conflicting information on retrofit and find it hard to know where to start. This is because information is often siloed and also too generic to be useful. There needs to be more emphasis on whole house retrofit and the benefits for health, well-being and comfort that good quality retrofit can provide. I'm also working with Claudia, who's going to speak later, and a colleague from UCL to design research on accelerating the uptake of low-carbon heating systems such as heat pumps. The current uptake of low-carbon heating is more than 10 times below where it needs to be to reach our climate targets. We're still developing our ideas, but we believe that this is a complex socio-technical challenge which requires a systems approach, considering both demand and supply sides and combining technical aspects, household perspectives and policy levers to accelerate the low-carbon heating transition as part of whole house retrofit. A final project to mention is a systematic literature review of whole life carbon and retrofit that I and a colleague from Bristol are currently working on. As I said before, assessing embodied and whole life carbon is very important to make sure that retrofit makes real carbon savings. So far, we've analysed over 1,000 abstracts from 77 countries, and we're preparing a paper on our findings while working on further analysis of the full papers. I'd like to conclude my very swift gallop through my research by saying that one of the things I enjoy about researching the built environment is that there's significant potential to have real-world impact and to make a useful difference, not only to critical carbon reduction to help mitigate climate change, but also to improving people's experience of their buildings and environment. Thank you for listening, and I'd welcome any questions when we get to the question point.
Thank you, Freya. That was really interesting. Yeah, sustainability. Right, we'll come back. We'll come to this later. I've got a question or two. Anyway, we'll get to these later. So I'm going to introduce the next speaker now. The next speaker is Alice. Alice is a lecturer in sustainability and the smart environment in the School of Engineering and Innovation. She's also an associate lecturer on a level 1 environmental module. She previously completed a PhD at the OU only last year, and her research interests include biogeochemical cycling and the environmental impacts of waste management. So Alice, if you could introduce yourself and take it away.
Thanks, Tony. I'm just going to try and share some slides, so give me a shout. That looks okay.
Yeah, we can see them. Just sticking in the presentation.
Brilliant. Yeah, so thanks for the introduction. So my name is Alice, and as Tony said, I'm a lecturer in sustainability in engineering and innovation. I'm also an associate lecturer on an environment module, but actually I also, just going a little bit further back, completed my master's in earth science as a distance learning student at the OU as well, before then doing my PhD, more kind of full-time study. So I've had experience of a number of different qualifications and roles, a little bit of everything at the OU. Today I'm just going to really quickly summarise some of the research that I completed as part of my PhD. And then I'll talk a little bit about some of the different research and things that I've got going on in my role as a lecturer as well. So during my PhD, I investigated trees growing on closed landfill sites in the UK. So when these landfill sites are closed, when all the waste has been buried, there are various different ways that we can remediate them. And one of these options is to plant trees on top. So not only does that make the sites look a little bit nicer, it also helps with things like the stability of slopes, and it stops water getting into the waste that's buried underground as well. So my research focused on these trees growing on these former landfill sites and whether they are emitting greenhouse gases, with a particular focus on methane, carbon dioxide, and nitrous oxide as well. So these greenhouse gases are produced in the waste when it's buried, so underground. And previous research in natural ecosystems, in wetlands, had actually shown that when trees are planted in these environments, they can draw these gases up from the underground area where they're produced, up through the roots and stem of the tree and emit them to the atmosphere. Now, this is a really important emissions pathway because it bypasses the very top aerated layer of the soil where some of these gases could otherwise be broken down before they're emitted to the atmosphere. And I've got a little diagram just showing that kind of emissions pathway on the slide here at the moment. So coming back to think about landfills, my PhD research looked particularly at trees growing in these landfill environments and thinking about whether if we plant trees on these landfill sites, whether that's going to lead to these gases being drawn up from the waste and emitted to the atmosphere. And that's really important because previous research had looked at the emissions from the soil and the kind of top surface of the landfill site, but not from the trees. And really it was to gain an understanding of whether we should or shouldn't be planting trees in these landfill environments. So just to really quickly talk about kind of what I actually did, I've got a couple of images on this slide. So I visited different field sites and I took a lot of different measurements, and I measured the amount of these gases being emitted or taken in by the tree stems. And there's some equipment in the photo on the right that you can see. So I had these chambers attached to the tree stems themselves. And then I could work out the concentration of these gases within those chambers over time using a greenhouse gas analyzer, and that's the big yellow box just below the tree in the image. And then once I knew whether these trees were emitting or taking in these greenhouse gases, I could then draw comparisons between different tree species, different landfill sites, between different months of the year, and also between trees growing on landfill and trees in more natural environments as well. So overall, I discovered that by not measuring the emissions of these gases from trees on closed landfill sites, then it's likely to result in an underestimation of the total emissions from these managed landfill environments. But when I then compared that to more natural environments, I found that actually the trees on landfill sites weren't emitting kind of atypical levels of these greenhouse gases. So actually, kind of on the whole, the recommendation is that we can plant trees in these environments without them kind of exceeding the natural levels of greenhouse gas emissions that have previously been seen in natural environments. And so once I kind of finished getting all the results together, I could then share some of my research, and I did that by publishing some journal articles on different subjects. And I've also been to some conferences and done some presentations as well. And you can see the image on this slide is me earlier this year in a geoscience conference in Vienna. It looks like there was only one person in the audience, but I promise there were more people there than just that. So that was my PhD research, and now as a lecturer, I'm trying to build on this. I'm still interested in looking at trees growing on closed landfill sites and the greenhouse gases that they're emitting and kind of how they're growing. So that's something that I'm going to keep developing in my role as well. And then really quickly, I just wanted to highlight a slightly different angle of my role as a lecturer and a slightly different type of research. So I'm also doing some scholarship research at the moment. And I'm looking at investigating the progression of OEU STEM students from taught courses to postgraduate research, so to PhD and MPhil courses. And this really is to gain an understanding of the current pathway that we have from taught courses to postgraduate research at the OU, and also to understand the decisions that students make in relation to this and understand why they make these decisions as well. So I'm assessing the current progression rates, reviewing some of the modules and qualifications that we have in terms of how they prepare students for postgraduate research, and conducting some interviews and surveys as well. And as I say, hopefully that will just give us a better understanding of that pathway, and maybe give us an idea of some follow-on projects that we could do to maybe improve this if that's required. And then just one very final point from me. I just wanted to share some details of an event that's happening quite soon. So I'm on the organising committee for Soapbox Science, which is an event that happens around the country, but we're organising an event in Milton Keynes on July the 6th. It's happening in Centre MK in Middleton Hall. And it's a really great event that promotes women and the science that they carry out. So I'm aware that not everyone listening will be in or around Milton Keynes to attend the event, but it is a national thing, so do seek out an event near you if you can. And I've just I can give the link out, or there's a link on the slides if you want some more information as well. So that's it from me, and I'm happy to answer any questions later on.
Thanks ever so much, Alice. Really interesting work. Okay, so I'm going to introduce our next speaker now. Our next speaker is Soteria. Soteria has a background in electronics engineering, biosensors and nanotechnology. She's worked at various leading European and UK institutions, in Switzerland, in Nottingham, the Cancer Research Campaign, Rutherford Appleford, etc. She is currently employed in ENI as a senior lecturer in bio-nanotechnology, and I'm amazed I got that all out, and electronic engineering. Soteria is internationally recognised for her work on biosensors, biomedical, micro, nano, electromechanical systems, blimey, and energy harvesting from the human body and bioelectronics. Take it away, Soteria, for your 5 minutes.
Thank you. I think it's because of my age. We can add all these words, but it's amazing, the young people also, presented very interesting research. So I will try to share some slides. Can you see my slides? Because I cannot see the screen.
At the moment, they haven't popped through, but something's happening.
Oh,
here we are. There we go. Yeah.
Surprise, surprise, my screen is, yeah, okay, that's better. Okay. First of all, thank you for inviting me. This is very important, if I can say, workshop or conference, or, to talk about these showcases. It is, first of all, I would like to start with how I built up my career. So I have a first degree in electronic engineering, and I got this in the beginning of '90s. So I have seen a lot of developments and changes in this field. So I have also a master in biomems and nanotechnology from Cranfield, and also a PhD on biosensors and optical biosensors. My research fields means, as I said, I'm working in this field for nearly 35 years. So I worked in a lot of different projects and research institutes as well. So the main fields, it is, bioelectronics, bioengineering, and then concentrate on biosensors, optical, electrochemical, and also analytical chemistry techniques, because are necessary. It's the heart of the biosensor. Micro nanotechnology is necessary in biomems, means it's for the microfabrication techniques. Microfluidics, it's multidisciplinary field when we talk about biosensors, and also other techniques, means for detection. And also, recently, we're using a lot 3D printing. They help us a lot in microfabrication. Also in the past, I worked in project, electrospinning, electrospraying technologies, and also how to miniaturize the biosensors in order to have a product at the end of the day. So, from, leaving the lab and have the real product. And I will, it's I can talk for different projects for a very long time. So here I think I will concentrate only to a recent project we developed. So my PhD student actually, he submitted his thesis and he has his viva beginning of July. So it was the development of a hybrid microfluidic platform, which we could harvesting energy from the human body. What it means from the human body, it means from the pulsation, or the arterial pulsation. So we're using this. Why we need this? Yeah, it's extremely important. Means I worked in the past many, for a long time on diabetes technology, and specifically, the biosensors. This sensor, maybe you have seen, if you have, if somebody is diabetic means type 1, it's or type 2 means they need to check their glucose levels. So they have to do this finger prick, means to take a drop of blood from their finger and find out what is the glucose in their blood. The trouble is now everything is moving to continuous monitoring, not just, means it's not good enough just to take 2 or 3 times per day some numbers and calculate if you need insulin or to control your diet as well. So it is so all the technology now is moving to continuous monitoring. You can call also wearable this technology wearable biosensors as well. So there maybe you have seen these devices. Means this is example from Abbott. There are 3 with FDA license, means there are 3 devices in the market. So these devices, a big disadvantage which they face, it is that they need, of course, batteries, and they need, to remove them between, the battery lasts between 1 week to 2 weeks, and then they have to remove it, change the battery, insert it again because it's a needle, and also sometimes you don't have connection. Anyway, there is this serious issue with the energy because they take data and they need to transmit this data. So of course they need energy. So it is. So this is this was the idea. So what we worked means, as you can see, how you can what energy you can harvest. So that's what we did. Means the pulsation. Means this. The heart is a pump. So you have this constant, very low levels, but constant is there. So if you can start, harvesting and keeping this, and then charge the device, this is going, to change the game, and keep the device for longer. For a lot of in healthcare, they're very well known. What are the advantages of this? Finally, yes, we managed to. My PhD student. Igor, he managed to develop this. We used a lot of technologies. Means first of all, we had to do simulations. So we used a multi-physics package called COMSOL. And also, his background was in electronic engineering. So he had to build also circuits and to make this working, autonomous. Of course, what you can see on the screen, it is just it's the oscilloscope and also the design. So a lot of prototypes. How we made it means we used a lot 3D printer because you could 3D printer is a big advantage for the when you are doing experiments, because any idea or any change you want to do it, you can immediately implement this and have the product. So you don't have, to send your design and then wait to receive it and then try new things. So, and finally, it is as it looks, means it's a watch-like wearable device which can harvest this pulsation with a, means I'm not going to details because it's more, maybe we need more time to explain this. Finally, means what we're planning means in life you should have vision. So yes, definitely we have vision means for to make this LINIC technology center at national and international level, of course, in wearable and biosensing technology. Also, this cutting edge technology, which we should have the appropriate labs. And it is not only means just I present a very small part of the work, because also we have other developments on biosensors for healthcare applications. Also, we're using nanomaterials in combination with the biosensors. So we need, so we increase this. We have also, because maybe from my previous, work experience, so we have a lot of collaboration with European colleagues and also in UK as well. And we have to maximize this potential. So you need to have vision and look things open to new technologies. Thank you for your attention.
Thank you, Soteria. That was really, really interesting stuff. Huge potential, I can see. Okay, we'll now move on to our final speaker. Our final speaker is Claudia, who is Professor of Design here at the OU. She did her PhD part-time at the OU when her first child was a baby. She's worked for nearly 10 years in the Engineering Design Centre in Cambridge as a postdoctoral researcher and came back to the OU in 2008. So we're slightly overrunning, Claudia, but you take your 5 minutes.
Oh, thank you. And Sylvia has got my slides. Well, welcome to my presentation. Like Soteria, I've been doing research for the last 35 years, so it doesn't neatly fit into a 5-minute presentation. So I thought I'll just give you an overview and talk a little bit about the sort of evolution of ideas. I've always been absolutely fascinated about how people design products. Everything that surrounds us is designed by somebody. People made decisions about absolutely everything, from your curtains to your cars to your cities, and these decisions have got an enormous impact on the lives of everybody. And my research is about trying to understand what's going on in these design processes and supporting designers in their design processes as commercial designers. And so a lot of my research has been about studying design in its broadest sense as a professional practice, and to develop tools and methods to support people when they are designing. And design is, for those of you who study design, of course, will know, covers a very, very broad range of things. And Herb Simon said so nicely that designing is about changing things from one stage into a stage that we prefer. So this covers really everything. But my research has mainly been focusing on engineering design, on the built environment, and also on fashion. I started by doing my PhD on design processes in the fashion industry. It looked at communication between knitwear designers and knitwear technicians. And while this sounds a bit niche, it turned out to be absolutely fantastic, because knitwear is basically complex engineering in a nutshell. It's a sort of non-linear system with discrete elements that need to be put together and supported. And it's because it's a relatively simple product, you can study the design process and you can study it in multiple organizations. And then later on, when I moved to Cambridge, I was packed off to study helicopter design. And that was much more challenging to study because, of course, you can't study the design process of an entire helicopter. You can only kind of prod it and probe it. And I've done a little bit of that, and I'm going to talk about this in a minute. But I just wanted to talk about a little bit about the range of things that I cover or have covered over my career. And part of this is about design processes. So in the moment, I'm looking into future trends in engineering design and into sustainability in fashion. And both of this is around how do people design? How can I help them design? And I've also done a lot about the theoretical underpinnings of design. So I've done quite a lot of work on philosophy of design. I've got an undergraduate degree in philosophy and studied mathematics and artificial intelligence before doing a PhD in design. So I've got a very broad background, and I'm trying to apply this to a lot of aspects of design research. I'm just going to go into a little bit more detail on the next slide, Sylvia. Can you move to the next slide, please? Thank you. Oh, is that an animated slide? If just keep going and animate everything. I'm sorry, I forgot that was totally animated. Just as the example, I've done a lot of work on engineering design over the years. Engineering design is looking at, no, previous slide, what happens if we change part of a product, what is the implications on other parts of the system and on part of the processes. And I did the majority of this work when I was in Cambridge, and over a multitude of case studies, we were sort of covering the whole range of the design process from the preconception to the disposal, and looked at various aspects of this. And that's what you often do when you do research, that you start at a very specific point and then you eventually start filling in the gaps until you have a really good overview and you become a real expert in that particular area. But then what often happens is that you pick out one particular aspect and again go into much more detail. And I got very interested in margins on design, which is a concept that aerospace is using, that you design something to a requirement, then you add a safety margin, and then often there is more capability on that system. Then a lot of the structure of the design process came out of managing those margins. So I was trying to find somebody who wants to do a PhD on this, and everybody ran a million miles. Now I understand that they definitely had a point because it's a very challenging topic. But when I came to the OU, I again tried to work on design margins, and we got a PhD student who looked specifically at design margins. So next slide, please. And this is some more concepts of the engineering design that came out of the engineering design research. And the margins that I've just mentioned are in this diagram on the left-hand side, where we were looking at whether a component would propagate to, or change would propagate to another component. So next slide. And then we started to look at design margins in the context of trucks and of GKN, which was on the non-rotary component of jet engines. So again, it's the application of ideas to a wide variety of different things. And we were trying to formalize what margins would be. And we were looking how it was playing out again in the design process, and realizing that people referred to this under a lot of different labels and therefore were double counting things. And again, this is a lot of this trying to understand where are the problems and processes, how can we help to conceptualize people, and then how can we develop tools and methods to support them. So next slide. And this is something that I'm working on again now around durability. And that's again related to design margins, because if something is over-designed or is larger than necessary, it often also lasts longer than you would expect. And that got me into thinking about how can we make products more durable and what are the downsides of durability, because often there is a cost associated with this. So on the one hand, in the moment, I'm doing quite conceptual work with a colleague from the University of Bradford, where we're trying to develop a framework for durability. And I'm also supervising a PhD where my student is looking at mending in textiles. And again, it's about durability, but in a different context, even though that particular sock is probably beyond redemption. But what I wanted to show you is that as you go through a research career, you end up having a very broad range of topics that you work on, and you have to be quite opportunistic in terms of where can I get money, whom can I work with, and also what are the changing topics of the time. That when I started my research, it was very much about efficiency in industry, industrial processes. And now we are moving much more into sort of thinking about sustainability, thinking about circularity. So the work is now set in the context of circular economy, but it is still the same ideas, and none of the problems we looked at in the 1990s have actually gone away. We still have to worry about communication for people in teams. We have to worry about collaboration. We have to worry about modeling processes, and all of these things continue. And researchers often revisiting topics over many, many years. I think that about covers it for me.
Lovely, thank you, Claudia, for that overview. Very interesting career. I think I'm now going to be handing over to Sylvia, who's going to chair panel discussion, and we can take questions about the presentations, and we'll be discussing some other issues as well, I think. Sylvia.
Thank you, Tony. I can say, I think Simon has the hand up. I don't know whether that's the desire to speak or just a legacy hand.
Sylvia, we have reached out to Simon in the chat, Q&A, and by email, so I'm not sure if that's a real hand. If it is Simon, you can unmute and ask your question.
Okay. Otherwise, I would start with the questions that arrived through the registration form. So, since we are celebrating the International Women Engineering Day, the first question will be for the engineers in our panel. So will be first Sotiria, then Sadrie, and Freya. The first question is, how did you get into engineering? Who is your inspiration? Sotiria.
Yes, first of all, I have to admit that going to engineering it was not something unusual in my family. My old sister studied mechanical engineering, so despite and also means in 80s, 90s, were not many. Maybe 1/3 of the students were women, so it was not so difficult. But never in my life I was thinking, men and women is what I wanted to do. So electronics, in 80s, 90s, where, maybe most of you, were not born that time, but it was, it was a, flourished that time with a lot of innovation, a lot of new things. Means laptops did not exist. We had a huge, screen, and to send a message, no, it was just, a few words, just a, text, And that's I use, to communicate with my husband. Okay, that time. so what I'm saying is, in life, you should not follow, stereotypes. That's and I never, okay, maybe other people have problem, but I never felt that I was, disadvantaged because I was woman. And even now, means I can, I did also 10 years undergraduate, teaching. So I used to teach, electronics and advanced electronics. And the first day, entering in the lecture room, the boys, usually, yes, in telecommunication school, 5-year studies, so it was quite high. They used, Mrs., we have electronics now. I said, okay, sit down and we'll discuss this. So what I mean, it's, yeah, you gain this, respect and it's important, you should have passion, you should want, to go that route. And you should not have, barriers. So I never had barriers and I continue this. So that's my experience. Thank you.
Thank you, Sotiria. Talia? Sadrie? You're mute, Sadrie.
I'm so sorry. Getting into engineering, to be honest, it was an ideal choice for me. Because when I was at high school, I was super into math and solving problems. And also my brother, who was studying chemical engineering at that time, was a big inspiration for me, because all of the time we used to talk a lot about his project, his courses. It was really sparked my interest at how can engineering help us to solve the real world problems. And both these reasons that I was super interested in math and this kind of problems, solving the problems, and in my area especially, the wastewater treatment, this idea that I can help to reduce the pollutant and have the clean water, it's really keep me motivated and I really like it. So now I'm happy with choosing engineering before. Yeah, all of these reasons help me to choose engineering.
Thank you, Sadrie. Freya, your story is a bit different. What about you?
Yes, so I'm sort of a pseudo engineer, I think, probably really, rather than a proper engineer, but that's all right. So I suppose I became interested in engineering during my OU degree, where I did a eclectic range of modules around geology and sports science and archaeology and a whole range of things. Yeah, I then did one on renewable energy technology and engineering module, and I really enjoyed it. I thought, oh, this is great. I enjoyed the mathematics, and I liked the fact that there were fairly solid kind of actual answers to some of the questions. That was quite nice, particularly as I'd just done one on international environmental policy, which was frankly depressing in that there really weren't any answers and it's all really complicated and difficult. So that was quite fun. And the tutor on that module was also the first person to suggest that I should possibly do a PhD. So that was something to think about. But I'm also really interested in history. So I actually went off and did a master's in military history at Glasgow University after my PhD, because I was going to become a historian. And then I thought, well, this is very interesting, but it's not very practically relevant to, saving the world and all that kind of stuff. So I thought, oh, well, actually, maybe I should do a PhD in something sort of environmentally sustainability related. And I was very lucky in that I was able to design my own PhD that involved sustainability and things and a bit of history around historic buildings. So that was great. So yeah,
that's really
engineer by accident, I think, around the edges.
Thank you, Freya. So let's pass now to Lisa and Claudia, the designers in the room, among our panel. So how did you get into design and who was your inspiration? Lisa, and then Claudia. Claudia.
Thank you. Okay, how did I get into design? My parents were always very craft-led, or my mum was an amazing seamstress, and so I was always around being creative. And we enjoyed the arts as a family. There was lots of music and theatre, and it was just generally the arts seemed to sway me. My grandfather was an engineer, and he was an amazing draftsman, and he taught me to draw. And it was something that I could never really then disconnect from. Drawing has always been part of me. As any designer would, the first thing I do to convey my internal ideas to external ideas is hit a paper and pen, or a marker and a big sheet, or a board, and anything I can write on, really. And it's kind of then start modeling ideas in front of you, and the understanding that we can tell stories through design, and we can help others with their stories. So the help that I have given, hopefully have given, to non-sighted and RNIB service users and Henshaws, and a lot of ability needs charities across the country with various assistive tools for creative measures. I felt that they were really involved in the process. They were considered experts, and they didn't consider themselves experts until they were introduced to that format. And even being part of that process has really helped many of the people I've worked with to really look at what they're doing and how their expertise from their condition can really help with new inventions of their own. And how they related to the research was then renewed for them, how they connected. I've got something to bring to this table. I have my own skills, and I have creativity that this research has helped me tap into, which is massive.
Thank you, Lisa. That's amazing. Claudia, what about you? Who was your inspiration, and how did you get into design?
I'm not even sure I say I would be a designer. I came into this in a very curious way. I've always knitted, and I still knit. I knitted in lectures, and somebody told me that I should do something on AI and knitting as a master project. And I thought, you're utterly crazy. But then thought about it and realized that it actually worked very well. And that got me eventually into a PhD on knitwear design. And I got interested in design at that point. And I'm more a design scholar. I think for me, the role models were probably more about becoming an academic than becoming a designer. And I think I was also, I'm still part, I think, of pretty much the first generation when you had a lot of women in academia. There were some women who were maybe 10 or 15 years older than me. And I think for me, the really important thing was to find women academics who have actually managed to combine families with being an academic. And there were just some that had already had bigger children, and I found that very helpful.
Thank you, Claudia. Let's now listen to Alice and Tony about their experience with environmental management. So the question is the same. How did you get into environmental management, and who was your inspiration? Alice.
Yeah, I think I've had a bit of a kind of roundabout route, but always had an interest in kind of the environment and kind of nature. So I haven't always been interested in the kind of more applied science that I do now. So way back when I was in school, I enjoyed kind of geography, biology, those kind of subjects. And then actually went off and did a degree in conservation biology and geography. So I was very much more on the kind of conservation nature side of things. And then didn't really know what I wanted to do. So that's kind of why I did the master's with the OU. Because it was kind of flexible, I could work at the same time, and that was really useful. And even then I looked at earth science, so it definitely wasn't the kind of applied science that I'm doing now. But I think I got interested in the kind of trees side of things during my master's when I did a project that was looking at kind of trees and water use efficiency in trees. And I really enjoyed the more kind of independent working in that project. But even at that point, I didn't really want to do a PhD. It kind of wasn't the plan at all. And I actually then went and did some different jobs at the OU. So I've tried everything at the OU, basically. So then I kind of, someone said, oh, you could do a PhD, a bit like Freya, really. I'd never really thought of it until someone suggested it. And at that point, I then started applying, and I actually had a choice then between a kind of more natural sciences environment PhD and the PhD that I actually ended up doing, which is more on the kind of applied science, adding in that kind of managed environment landfill aspect. And I actually went for that one because I liked the fact that there was some kind of outcomes, more kind of tangible outcomes of kind of making some sort of recommendation or having some results that would be really useful. And that's when I kind of shifted more towards the kind of applied, more environmental management, the kind of natural sciences and environment side of things.
Thank you, Alice. Tony?
Oh, well, it's a bit of a circuitous route, really, because actually none of my family had ever been to university. And my parents owned a waste management company. So essentially, I decided to go to university, and then I was looking for an MSc to do, and I happened to see a PhD advertised in the waste management related area, and I don't know, I sort of ended up here. When I first came to the OU, it was 2001. It was very much more engineering focused, the school that I was, or department I was first recruited to. It only had 20 academics in, and I was the only woman academic in the engineering. It was Department of Electrical and Mechanical Engineering at the time. And all of the other women were the secretarial support staff. So it's changed a lot in the last even 20 years. I think the whole sector has moved tremendously. So yeah, it's for the good. But yeah, so I ended up here by accident, is what I'm saying.
Thank you, Tony. Now I would like to take the question from the chat. So the question is, if you could go back to the start of your research career and give yourself advice, what would it be? Who would like to reply to answer this question from the panel? Lisa.
It's a good question. I think all of us try to be reflective, but never really from this angle. Yeah, I think I would encourage myself to work between the lines. I was always, as a designer, things like in engineering are always in cycles or in systems, in process. We do have cycles of iteration and movement within the design cycle itself, but I've always found the best inspiration has been working between the lines. It's kind of that creative gap, that hole that you look for as a designer to find out not only what hasn't been done before, but how the problem fits into the hole and where the hole can be filled. And so, yeah, definitely work with your imagination as much as your pragmatic brain.
Thank you, Lisa. That's a very good advice. Anyone else would like to add to this question?
I think I can also come in on that.
Okay, so first Claudia and then Freya.
Because I think with research, it's important to figure out early what you want to achieve with the research career. Because if you want to make a career as an international researcher, you need to focus on an area that's up and coming and really, really push it and be very strategic about where you want to make a contribution, get to know the people who work in the areas, make sure that your work is being seen and that you get a big exposure. And the other thing is also to still be driven by one's passions and one's curiosity, because people who lose interest in their own research are just not good researchers and ultimately give up on research, that unless you really passionate about what you're doing, you're not going to withstand all of the pressure, and to a certain extent also the negative feedback you're getting, because as a researcher you need to be extremely resilient, because people are going to not fund your projects and not publish your papers and tell you all the time what's wrong, and very few people tell you what's right or well done or something. So you just have to be very resilient, and unless you have that sort of resilience, then you probably will ultimately struggle to make it as a researcher.
Yes, I agree. Resilience is a must. Freya.
I think I would echo Claudia in being resilient and motivated, but certainly being motivated in what you want to do, because you're the one driving things. You know, you're in charge of what you're doing, so you need to be keen on it and keen to carry on even when it's causing trouble. I think also being open to doing different things, because it's amazing how sometimes things that seem unrelated to start with can actually come in and be really useful. So one of the methods for my research, I ended up going, oh yeah, I could use that in my research, because I went to a talk about using art in, what was it? It was using art in something completely unrelated to buildings or sustainability or anything. It was just a talk I went to, could sound interesting. I went, oh, that would be a really good method. I could use that and I could apply that, and got some really good results from it. So that's good. And I think also as a practical issue, try not to arrange your PhD fieldwork when there's a global pandemic happening would be a good tip, if you could manage that.
I think also this one is a very good piece of advice. Sotiria?
Yes, I would like to add something, which maybe some people will like it, some other, no, but you should work hard. So you must, be hard worker with passion, as Claudia said. And because these days we pick up the easy, path in order to make things. And also we want, to do things in very short time. Means the experience, and also the respect, and also the knowledge. It's not something you can have it in very short time. So have patience, and also believe what the path you're going. Means the research has a lot of energy, and also a lot of innovations and paths, because you follow, what it is, the cutting edge of a specific field. So this does not come automatically. It does not come, I am, a lab person. So I spent long hours, maybe with no good results, but no good result is good again, because you exclude this and you go to the next stage. So means in what I would anyway advise, if I can, it is don't scare, don't afraid. Sometimes you have to be brave, and also don't protect yourself, to follow the easy way. This way doesn't have always this excitement. So keep the excitement on. That's my advice. Thank you.
Thank you, Sotiria. I really resonate with your words, absolutely. I'm conscious of time. We are close to the closure. I would like just to make a short question about designer and engineering to maybe Lisa and Claudia before closing. So from the registration form, we got this question. Is it possible to be a designer without being an engineer? Someone who says, I enjoy the designing aspect, such as design concept, research, design thinking, but it feels like a different area of study to make the concept real. What would you say, Lisa and Claudia?
It is. Many designers with various forms have created a career, maybe without knowingly being partly engineering. You could argue that some of the questions that designers are solving in a creative and processive and problem-solving intercept with engineering in quite a few ways, but maybe it's not acknowledged in that way, or maybe it's not known at the time. So yeah, it is perfectly capable. You are perfectly capable of becoming a designer without having to lean too heavily on engineering. But I do think it is in there somewhere, even if you are not overtly saying, I am engineering today, you possibly are as a part of the process.
I think I totally agree with what Lisa is saying, but also, of course, you can be a designer by designing things that are a long way away from engineering. For example, if you think about something like policy or health strategy or something like that, then you wouldn't necessarily have engineering as a topic area. But if you want to design products, especially complex product, it is very useful to have a background in engineering so that you understand what's doable and what's not doable. Even if you yourself don't do the engineering, it's helpful to have that background. For example, if you work with users or clients and you're trying to understand needs, it's good to know in the background what actually can be done and can't be done. So sometimes it's worth slogging through the engineering in order to be a good designer.
Thank you very much, Claudia. And we are at 1 p.m., so I think it's time to wrap up. I would like to thank all the speakers from today's session with a big round of applause. Thank you so much. Your research, your enthusiasm, your advices has been wonderful. And I would like also to thank very much Fiona, who has helped me to organize this event. Thank you so much, Fiona, and Kat to look after the chat. And please come all on screen for this last moment. Thank you, Fiona. Thank you to all the speakers. And we are with Fiona and with all the women in engineering and design organization committee organizing other events for later this year. But for now, the one I want to highlight is the Women in Engineering Day, which will be on Sunday, but the main celebration will be on Monday through a workshop. And that I think Fiona added the link in the invitation to this event. So thank you so much, everybody, for joining us.